And I'm welcoming you on problem B, squares and cubes of Codeforces Round 762, Div 3. So the question says squares and cubes. Polycarp has squares and cubes of positive integers. Here's the beginning of the sequence of numbers he likes 1, 4, 8, 9. Okay, he likes squares and cubes. For example, give a number n, count the number of integers from 1 to n that Polycarp likes. Okay, so let me explain you the problem statement. It's quite wait a second. So it's quite easy. So I have to deal with only squares. Okay, I have to deal with squares and I have to deal with only cubes. So I have to take only squares and cubes. And for if I'll let me change the variables because it will be confusing. So I have to deal with only squares and cubes, and what I have to do is I have given number n. I have to count the number of perfect squares and perfect cubes that I encounter from 1 to n, both included. So what will I do is, what was my approach? Okay, what if you see such a problem, how will you approach this? We have to deal with squares and cubes. So what I will do is, I have directly taken the square root of n as my answer. Okay, it will always be included. And what I have done is taken it as int, or in C++ it will be floor. If you are not aware of the floor function, you can look up on the Geeks for Geeks. Okay, floor is basically the, you can say, the greatest integer which is less than or equal to that number. Yeah, which is, yeah, I'm correct. So I have taken the square root of n as itself. For example, let me quote an example. If I take the example, if I am given with 101, this is the value of n. So under root of 101 is 10. By after taking the floor function, its value is 10. So there will be 10 perfect squares till 101. One, if I ask you to write, these are 1, 4, 9, 16, 25, 36, and you can quote up to 100. So how many numbers are these? There are 10 perfect squares till 101. Okay, up to this part it's clear. Okay, so after that, what I have taken is, yeah, what I have taken is, I have taken the cube root of this number, and I cannot directly add it to the answer, because suppose there is a number 8. It can be expressed in two ways. What are the two ways of expressing? Oh, sorry, not 8. It's yeah, take 64. So I can write 64 in two ways. It can be either written as 8 square, or it can be written as 4 cube. So if I directly add this to the answer, then these duplicate cases will definitely arise because they are the same in itself. So what I did is, I take a loop from what? I take a loop from, you can say, 1 to cube root of n, to cube root of n, and I checked at each step if the number I am getting is a perfect square or not. So suppose if I is a perfect square, if I is a perfect square, is a square, then I subtract, then what I will do is subtract 1 from the answer, whatever the answer is. And what is the answer, by the way? I told you what is the answer. The answer is this thing, square root of n plus cube root of n. If you see the code, okay, here's the code. Let me increase it. Yeah, so the answer is int of square root of a, this a is the given number, plus int of cube root of a, this is the power function, it is a quite simple function. You can geeks search for it and everywhere on anywhere on the Google, and you will answer it. You will find it, and I will add this special case. Okay, this special case. I don't know why I was getting this error, but I just noticed it in the test cases. What I have done is, if it is equal to 10 power 9, then it was giving the cube root of 10 power 9. Cube root of 10 power 9 in Python is actually was actually giving me 999, was giving me 999.999 something. Okay, it was not exactly uh, it was not exactly 1000, not exactly 10 power 3. Let me show you, it will be available. Yeah, see, the cube root of 10 power 9, it was giving me. By the way, it's the Python idle. If you are new to Python or just doing it, so it's the Python idle. You can directly execute single statements from here. So okay, so when I did the cube root of 10 power 9, then it was giving me 999 instead of 1000. So I was getting one less in my answer. So I just added this case. If this is equal to 10 power 9, then 1 will be added to the answer. And I take the loop from 1 to cube root of that number plus 1, because in Python loop goes from 1 to the maximum limit minus 1. And if that number percent 1 is 0, if that number ka square root is okay, the square root of that number, of that cube, of that number, okay, of that number is divisible by 1. What this means is, it's a perfect square. So let's suppose it's 4, and I'm taking the cube of that number, and then I'm taking the square root of that number, cube of that number, then I'm taking the square root of that number, that gives me 8. And if this is an integer, I'm getting a perfect integer, then this won't be included twice, and 1 will be subtracted from the answer. So if this is an integer, percent 1 equal to 0 checks for the integer, and I'll subtract 1 from the answer, and it will give me and I'll print the answer. So these two questions I was able to do quickly. If you see the standings, yeah. So I am currently at 2000 out of how many? Oh, nice, 16,000. Yeah, so first question was 3 minutes and the second was 15 minutes. So I was able to do it quickly. Hope it helped. Please like the video. You know the drill. Subscribe to my channel and share the video to anyone who might find it useful. Okay, I just forgot a mandatory smiley. Weird. Hee. Bye. So there is hello. So I'm continuing the problem B solution, squares and cubes, and there is a my solution has been hacked. It's been hacked, and I just understood the issue, and its issue was similarly which I told you regarding 10 power 9. So it will be okay. Wait, let me tell you the error which I'm getting. So suppose there's a number which is a like power multiple of a 3. What I mean is, it's 10 power multiple of 3. That means it can be either 3 zeros, and if I take as 1 by 3, then it will return me 9.99. And similarly, if I take 3 more zeros, it will again a power of 3, and it will return 99 point something. Similar was the case with 3 more zeros. Okay, and it was giving me 999. So in all these cases, you have to consider an extra, like a plus 1, extra plus 1, if the number is exactly equal to these numbers. What I'm saying is, see the solutions. Okay, where I have taken as I have taken as a is equal to 10 power 3. They you have to write, what do you have to write? Wait, shit. Okay, what you have to write is, you have to consider three cases. First is 10 power 9. How many of these? 1 2 3 4 5 6 7 8 9. First is this, second 1 2 3 4 5 6, this, and 1 2 3. These three cases, if a is equal to three of these numbers, any of these three numbers, then you have to add 1. Okay, you have to add 1 to the answer, which I have not written the code with me, so I have told you here, where I have written plus a is equal to that. And if you don't want to do that, there is another approach to that. Another solution is, the constraints are very much less, so they are 10 power 9. So my overall complexity will be only overall complexity will be 10 power 4 plus 10 power 9, 10 power 3 actually, not 10 power 4. 10 power 4 is actually I have is like I have taken directly into consideration 10 power 3, which is equal to cube root of what, 10 power 9. Okay, so I have taken this 10 raised to power 3 loop, and you can actually take a loop like for I in uh, or you can take yeah, if you take while I cube is less than n, less than equal to n, you can maintain a set. If you make a set and then add these numbers, yeah, you can add numbers to that set. And similarly, if you take I square, which is less than equal to n, less than equal to n, and you add them in the I, yeah, and then you just print the length of that set. Yeah, this is the, yeah. So the length of this set will be the, what will be the answer, because uh, this set will directly eliminate the duplicates, which include the cubes and squares, and just eliminate the duplicates, and it will directly give you the answer. Okay, in earlier I have not taken these three cases into consideration. I have taken only this one, so these two are remaining. You can uh, you can proceed like this, or you can proceed like this, with two more considerations, the 10 power 6 and the 10 power 3. Hope it is now clear, and I will upload this video along with the other three videos, and you can, I'll just link these two videos together, and you can consider it also. Okay, or I can just add this to the end of the previous video and then upload it again, something like that. Okay,